In this video, I'll talk about constant pressure reactions and a new function, enthalpy. First, the internal energy change of a system is equal to Q plus W. When the system pressure is constant, we say it's an isobaric system. And we have delta P equals 0. Delta P is the change of pressure. And then we have this delta E, the internal energy change, under the isobaric condition is equal to Q sub P plus W sub P equals Q sub P minus P times delta V. Because P is a constant, we can put this P inside this delta sign, and then we have Q sub P minus the change of the product of PV. Again, we can equate P times delta V and delta PV only if pressure is a constant. And then under the isobaric condition, we have this Q sub P equals delta E plus delta PV. And we can combine the change of E, the internal energy, and the change of PV. Q sub B equals the change of the sum of E plus PV. So in short, if you measure the heat flow of a system under constant pressure condition or isobaric condition, this Q sub P is equal to the change of the sum of E plus PV. And this is not very convenient. Therefore, we define a new function H. H equals E plus PV. The reason we define this new function is because most chemical reactions are isobaric reactions for convenience and safety reasons. Therefore, it's more convenient to say Q sub P is equal to the change of this new function H. H is also a state function. This is because E, P, and V are all state functions. E, P, and V only depend on the state of the system. Therefore, H only depends on the state of the system. From the previous lecture, you learned that Q sub V equals the change of the internal energy. Therefore, I want to tell you this. The heat flow is equal to delta H, and the heat flow is equal to delta E. Both statements are correct. You need to specify the condition. Under isobaric condition, Q sub P equals delta H. Under isochoric condition, Q sub V equals delta E. The enthalpy change of a reaction is equal to the amount of heat that flows into or out of the reaction system. If heat flows into the reaction system, delta H of the reaction is positive. If the heat flows out of the reaction system, delta H is negative. When delta H is positive, we say it's an endothermic reaction. When delta H is negative, we say this is an exothermic reaction. We can use this equation to do some calculations. Delta H of a reaction equals the heat of the reaction under this constant pressure condition. Let's work on one example problem. The heat capacity of a isobaric calorimeter is 8.0 kilojoule per mole per K per Kelvin. The combustion of 5.0 millimole of a chemical increases the temperature of this isobaric calorimeter from 293 Kelvin to 296 Kelvin, or you can say from 20 degrees Celsius to 23 degrees Celsius. Our goal is to compute the enthalpy of reaction in kilojoule per mole. So first, let's look at the amount of heat that flows into the calorimeter. It is equal to the heat capacity of the calorimeter times the temperature change. We have the heat capacity here. We compute the temperature change, and then we know the Q of the reaction equals negative Q of the calorimeter. And therefore, we have this Q of the reaction under the isobaric condition equals negative 8.0 kilojoule per Kelvin times the temperature change, which is 3 Kelvin. The result is negative 24 kilojoule. This negative sign means heat flows out of the reaction. And pay attention to this constant pressure condition. And then we have this equation: the enthalpy change of the reaction is equal to the heat flow of the reaction under isobaric condition divided by the number of moles of the chemical. Therefore, we use negative 24 kilojoule divided by 5 millimole. The result is negative 4,800 kilojoule per mole. The meaning of this number is if we combust 1 mole such chemical under constant pressure condition, the enthalpy change of the reaction is negative 4,800 kilojoule, and the reaction is exothermic.